In problem number 2, we have a block of mass of 8.4 kilograms moving on a horizontal frictionless surface with a speed of 4.20 meters per second, making a perfectly elastic collision with a block of mass M, capital M, at rest. After the collision, this block recoils with a speed of 0.4 meters per second. Next, the blocks are in contact for 0.200 seconds, so that means that the change in time is going to be 0.2 seconds. Now they're asking us the magnitude of the average force on this block while the two blocks are in contact is closest to what? So the equation that we're going to use is the following. Force times the change in time equals the change in momentum. We have the initial velocity being 4.20 meters per second positive because it's going to the right direction. In the final velocity, we have the negative 0.4 meters per second because it's going to the left. It's going the opposite direction. Next, we have the mass being equal to 8.40 kilograms and the change in time being 0.2 seconds. So what we're going to do is just plug in the values into this equation and solve for the force. What I just did is rewrite the change in momentum as mass times the velocity, the final velocity, minus the mass times the initial velocity. So we plug in the values and we get an answer of force being 183.2 newtons. In this case, it's going to be answer B.